again in case you didn't want all of it.
All right, so what we're going to do is, remember, I'm a big one on building that inclusive community. I want when we're a group of learners to learn about each other. So we're going to do an activity together. Each one of you should have gotten this Venn diagram. Okay? So what I want you to do is take a pencil or a pen or a crayon or a marker, whatever you have, and take your Venn diagram, and I want you to stand up. Oh, really? 8 o'clock in the morning, you're going to make me stand up and interact with people? Uh-huh. So, here's the deal. I want you to stand up. I want you to take 10 giant steps around the room. Go ahead. Anywhere around the room. Stay in the room though, don't leave. Okay. Kyle, I don't think you're going to take giant steps around your room, are you?
Yeah, it's not very big.
Okay. Okay, hand up. I don't care. Pair up. Pair up with someone. Closest person to you. Hand up, pair up, closest person to you. Okay? You guys can be together? You guys together? Okay, everybody has a pair? Okay, now, find a spot and sit down, and then I'll show you how, that's your partner. Find a spot and sit down, and then I'll show you how to do the Venn diagram.
Excuse me, whose backpack is this?
It's fun.
It's so cute.
Okay, so here's what you're going to do. A Venn diagram has two distinct circles that overlap, right? So what you're going to do is you're going to write your name on one line, and you're going to write your partner's name on the other line. So go ahead and do that. Kyle, I guess you're stuck with me again.
Okay.
We'll mix it up so that we get other people to partner up with you, okay?
Whatever works.
Yep. Okay, then, so, if your name is above the left circle, that's you. If your partner's name above the right circle, that's them. What do you suppose this intersecting thing is for?
What we have in common.
What you have in common, perfect. So, you're going to talk about yourselves, your interests, your likes, personal, not real personal things, but I mean like where you're born, etc. And you're going to put things that are different, that are just about you in the outside, but things that are common about you are going to go in the center. Okay? And I'm going to give you about 7 minutes to get to know each other. So, when I say go, you can begin. Go ahead and start. Okay, Kyle. Okay, so go ahead and what do we have in common?
I don't know.
Well, let's see. Well, I'll tell you, I was born in Ohio.
Ohio. I was born in Montana.
Okay, Montana. Okay, I'm old.
Get there.
You're young. Okay, what about your likes?
I like video games and computers.
I like computers.
That's in common.
So that's in common. Okay, hold on a minute. Okay, have any questions? You guys have any questions? You go ahead. All right. I like to travel.
It's not my favorite, but I like camping.
You like camping?
I guess that's a form of travel.
Yeah. Do you camp out a lot up there?
I wouldn't say a lot because it's a winter, but typically
Yeah, but if you can, my son and his girlfriend would camp out all the time in the summer.
Yeah.
Okay, Do they have any animals? You have a cat, don't you?
I do.
And I have 2 dogs. But I have a grand.
Not sure if that counts as similarity or difference.
Well, we can put pets. But I have a grandkitty that I love. What else do you want me to know about you?
I don't know. I guess one thing we probably have a problem is that I'm trying to be a teacher.
Oh,
Obviously.
yes. Good for you. I'm trying to think of, oh, I love sports. I love football.
Not really a sports fan.
Okay, that's it. All right. Okay, how'd it go? That's just a little humor in the music. Julie Andrews getting to know you. You know, so when you're teaching, you know, you could bring music into it, and you can bring some of that music that kind of applies to what you're doing. There's a man that published a book, his name is Jeff Green, and he has a book that's this thick. It has over tons and tons of songs, and they're listed by category, so that you could, like, if you needed a song about photosynthesis, you could look there and see what kind of songs might be kind of funny about photosynthesis. So, okay, so tell me about this activity. What do you think? Did you get to know your partner a little bit better? Okay, no? Yes? How might you use this in your classroom when you get a classroom?
When there's a new kid?
When there's a new kid? Yep. What?
Great idea.
Okay. Could you use it when you're comparing 2 concepts?
Yeah.
So, do you have to use this just to get to know people?
Oh, no.
No. So you could use it like if you have 2 concepts.
Any time to compare and contrast.
Right. Compare and contrast, like meiosis and mitosis, those type of things. How about, like if you're teaching social studies, you want to compare the Civil War with the Vietnam War, that type of thing. Okay? So this is just a good tool to keep tucked away. Keep it in your book, keep it in your notebook, because it's just a strategy you can use with your students to, number one, maybe get to know each other, or to do a review for content. Okay? All right, thank your partner, and you go back to your seats. Thank you, Kyle.
Thank you.
Okay. So yesterday, do you remember, or Monday, we were going to talk about scans. And there's 2 types of scans. So if you have your PowerPoint, you can get that out. If you're new, here's the PowerPoint, and here's the syllabus. So if you're new, here's one of each. Okay. So let's go ahead and get the handout that I gave you on Monday.
Today's the syllabus is huge.
Yeah, I know. It's what you put by your toilet, and you can just read through it. If you want that.
It's too cold to read on the toilet.
That's called multitasking. All right, so here's the deal, you guys. We're going to talk about these different scans, but what did I tell you about it? I'm not going to really test you over them. I just want you to be aware of them so that you understand the function of the brain, okay? So, there's 2 kinds of scans. We have the scans that look at a brain structure, and we have the scans that look at the brain function. So the structure is where it looks at the different parts of the brain. The function looks at how your brain operates or functions, okay? So the first one we're going to talk about is an EEG and an MEG. Electroencephalography. Can you say that 10 times? No? Do you want to say it 10 times? No. is the magnetoencephalography. So, here's what they do. Now, this is just for your background knowledge, okay? Just for your background knowledge. It determines how quickly something happens in the brain. It measures electrical and magnetic activity. If you look at it, an EEG has all these electrodes attached to your brain. And then the MEG has 100 detectors placed around the head to record magnetic activity. And they record changes as quick as 1 millisecond. Holy buckets, huh? 1 millisecond, that's fast. And then when a group of neurons respond to a specific event, they activate and the activity can be detected. And you're not exposed to radiation, which is probably a good thing, isn't it? So is this doing function or is this doing the parts of the brain?
Function?
Function, absolutely.
I think my son had one of these done. He stutters.
Oh,
and I thought
uh-huh.
he was having seizures, so we took him down here and they put little sticky things all over.
And they were measuring that activity.
Right.
That's pretty interesting, huh?
Yeah,
But
I was
they-
in there. It was quite interesting.
What did they find out?
No, he's fine.
He's fine.
I said, you have a brain, no, you're good.
Was he stuttered because he developed speech later?
Yeah.
My son had the same thing.
He's been in speech since he was 5.
Yep. And then as soon as, because sometimes when you develop your speech later, then all those ideas come and you can't get them out fast enough.
Yeah.
Yeah. And then once they have speech to help them sort through that,
Yeah.
that really helps. So he probably won't be in speech much longer then. Okay, so the good thing about this is it gives us information for, like, example, like why was Noah stuttering? And it found out that the brain activity was fine, but then they could prescribe what to do for him. So that's the whole point in these. Okay? These you're not exposed to radiation, which is probably a really good thing. Now the PET scan, positive emission tomography. Okay, it observes brain functions as well. It injects the subject with radioactive solution that circulates in the brain. Kind of scary, huh? Radioactive. The brain regions of higher activity accumulate more of the radiation. The computer picks up the concentration of radiation as a picture of blood flow, but the major drawbacks are, okay, it says 2 major drawbacks, but I have how many? 3. Okay, invasive nature of the injection, its use of radioactive material and not used with healthy children. What does that mean, not used with healthy children? So when would you use this?
When someone's sick.
Probably when someone's sick. And the risk of using that radiation is worth it to help remediate or help find out what's going on, right?
Yeah, my grandma just got diagnosed with cancer like all over her body last week, and they're doing a PET scan this week.
Are they?
Yeah, and so they're like sending her to the University of Colorado, and they're gonna do a PET scan, so.
Will you tell us
Yeah.
how that, how she, you know what the process was? Love to hear that.
Yeah. So,
Well, I hope that things turn out okay. God, it's scary, isn't it?
yeah,
Yeah, well, she has our blessings.
thank you.
But let us know, I'd like to hear how that goes for her. So then you have an fMRI. It's a functional magnetic resonance imaging. How many of you had an MRI?
I just barely got one.
Did you? On what?
My knee.
Your knee?
I had my concussion.
Concussion on your head?
My knee.
On your knee? I had one done on my knee. I hated it. Can't move. I can't imagine it doing on my head. You had on your head? You had your head in there? What was that like?
I don't remember those cuts.
Okay, I don't need to laugh at you, but yeah, you're right, you don't remember. So they took you right in after the incident happened?
Yeah,
Oh.
I went snowboarding and then I got back and then I went to the hospital at like 2 a.m.
So were you knocked out then?
I blacked out when I fell when I was snowboarding and then I fell asleep on the bus and then I woke up and had immense pain, so I went back to my room, turned off all the lights and thought I'd be okay, and woke up and started throwing up everywhere and went to the hospital.
So no wonder you don't remember, but could you imagine having your head under there? I just think I'd be too claustrophobic, but if you were concussed, you didn't know about it. Yeah,
I don't remember going to the hospital.
that's probably a good thing. Do they, I don't know, Has anything else on anybody that's had to go in under their head? Did they give you a relaxant or something?
No.
No?
I had to go in there like this and lay on my stomach.
You're
And my
kidding.
head was like in a pillow.
I love stuff.
And they didn't give you any relaxant or anything? No? And you did okay?
Yeah. My arm went numb.
Did it?
Yeah.
Yeah, I'm not claustrophobic, so.
Yeah, so it's a good thing you were concussed when you went under there.
It's like 30 minutes.
So what they do is they pinpoint brain areas of greater or less activities. It's painless. So actually, an MRI is not a bad thing, right?
Is this the one that's really loud?
Yeah, it goes.
Yeah.
It's like, my mom had one time in Bozeman. She said they played music.
Yeah, they played
They play music in mine.
The one in Great Falls doesn't.
No, my dad has MS, he gets a lot of
Oh, does he get it? Yeah.
He said it's just loud noise.
Yeah. And then there's the MRS, which is functional magnetic resonance spectroscopy. It's the same equipment as the MRI, but they use computer software to record the levels of the chemicals in there, okay? And they can pinpoint activity as well as the chemicals present at the activation site. What do you think? I don't want any of them. No. Okay, so why would I want you to know this stuff? Just to have the background information. And another thing is, this is what researchers are using for brain study now. They're using these tools. They're doing them so that they can find out what areas of our brain activate. Do you know that there is actually areas in our brain that activate for ADD students? Did you know that? They can actually pinpoint those areas. Did you know that there's actual areas in the brain that activate when you're reading? This is the kind of tools that they use for that. So I'm telling you that because this is research-based information. It's not just pulling stuff out of the sky. It's research-based. And so when we talk about brain-based learning, we talk about engaging students, it's research-based stuff. There's a base for it. Also, when you have parents and you do conferences and they're saying, why are you doing this goofy stuff like getting the kids up and moving them around while they're learning? You know, why are they not just sitting in their seats and why are you just not teaching them? You have research-based information to share with parents so that you have rationale for what you do. Okay? So then we have these things called neurotransmitters, and you have these in your brain, okay? You have brain chemicals. They cover the brain cells and they permit signals to pass between them or they inhibit them. So when you get hurt really bad, like when you're concussed and you don't remember it, your brain's shutting your body down, okay? It's transferring that information. It's just trying to protect your body. Wide fluctuations in the concentration of the neurotransmitters can change our moods, affect our movements, alertness, as well as interfere with our ability to learn. Neurosurgeons can use tiny electrodes to stimulate individual nerve cells and record the reactions. This is what's happened with my mom. She just had back surgery in September. And so they were doing some tests on her, some electrode tests on her back to see what nerves, when they were operating on her, what nerves were activating. Okay, here's what you do. Stand up. Stand up again. You're falling asleep on me. It's early. Your brains are still thin. Come on. Okay, let's have George. Would you lead us in a couple just stretches just to get us fired up right now? Anything. Okay.
The only stretch I do.
Is that all you do?
Yeah.
Okay, can you stretch out a little bit, do something a little bit different? There. What do you do before, what event do you participate in rodeo?
I calf rope and T-rope.
Okay, what do you do with calf rope? How do you,
I usually stretch my hamstrings.
okay, let's do it. How do you stretch your hamstrings?
Well, I usually throw them up on a panel.
Okay, we've got a table. Okay, we can do this. We can do this. All right, sit down. All right, see, that gets our brain going. It gets us fired up. How many of you smiled a little bit? Yes, come on. You can admit it. Okay, Kyle, did you do some stretches?
I stretch by lifting my coffee cup to my
There you go, okay. arm stretches. Okay, so here's what you're going to do. Find someone in the room that has the same color as you have on, or close to it. Okay, grab that partner and go to part of the room. Stand up. Grab that partner. You need your notes. You just need your notes. There you go. Grab your partner. Swing your partner up and down.
Can I join a group of blue people?
Yep.
Yeah, come on over.
Yeah, who do I go with? No one's wearing brown.
George, come here. I'm going to hook you up with Kyle.
Okay.
Kyle's in Columbia Falls. Right here's Kyle. You can talk to Kyle right here. Okay? All right, introduce yourself to your partner. Tell him your name. Okay. Here's what I want you to do. I want you to review just the 4 scans that can be done with each other. You're going to kind of quiz just a little bit so you understand a little bit. We didn't spend a lot of time on it. So what I want you to do is open up to the 4 scans. I want you to talk a little bit about them, and then I want you to quiz each other a little bit about them. Okay? So let's go ahead and begin. Start with talking about the 4 scans.
Determines how quickly.
Okay, so what do you got?
Yeah, there's a ECG and MEG.
I discovered
MRI, MRS.
Sounds right.
What
What do we got? The difference?
and not exposed
E, E, and everything.
There's 19 to 120 electrodes for fractional scales. MEG, there's 100 connected to the head. 1 year is electrode.
Electrode stuff for one drive.
Okay, and then
So what they're recording,
Oh, that's right.
Well, they're 2 separate. One's going to
electrical and magnetic. I think that's what we need to get out of it.
So they're similar, except one's electrical, one's
Electrical
magnetic.
and magnetic. PET scan reports radioactive. And the MRI detects right? So I think that sounds like the basic stuff. What's the difference between the MRS and the
How many are, need just a few more minutes? Okay, we'll give you a few more minutes.
So basically the MRI detects oxygen and hemoglobin. MRS detects
Okay, how are we doing?
okay.
Are we okay?
PET scan is radioactive. PET scan radioactive. MRI oxygen. EEG and MEG is magnetic. I think we got it.
Okay, thank your partner. You can go back to your seats.
Thank you.
Okay. Now, tell me that process of share pairing with your partner. How does that make the learning? You're still lifting weights, huh?
Yeah.
Did that help? Does it help discussing that? Okay. So, what what does EEG stand for? It's with electrical, so they look for electrical, okay? Yep, that's it. And then what is the M for? Magnetic. And what's the MRI?
Magnetic resonance imaging.
What?
Imaging.
Kyle?
Magnetic resonance imaging.
Right. Okay, and what's the MRS?
Magnetic resonance spectroscopy.
Okay, and what does all this have to do with anything?
It's the function.
It's the functions and the structures of the brain, right? And why do we need to know it?
See if stuff's wrong or to just learn about it.
To learn about it, to show that people use these things for research, to understand that when they're researching brain, that they're using these tools, and that's what gives us a lot of information. And also what you said is to help people heal, okay? So, traumatic brain injuries can really affect people in their learning, and so we're going to talk about that later on too. So basically, what's the implications for teaching? Why do we want to know this? Teachers try to change the human brain every day. Do you agree with that? Yeah, by how they teach and what they're teaching, they're trying to broaden your experiences, right? The more we know about it, the more successful will be in our endeavors, the more successful we'll be in teaching. If you know how to teach to students' brains, you'll be a more effective teacher. Now, tell me this, do you want to spend more time reteaching, or do you want to get it right the first time? Yeah, because when you get it right the first time and students are learning, you don't have to constantly reteach, okay? Think about a doctor. Don't you want a doctor that has done this research and learning on the ailment you may have? I mean, if I have cancer,
I want someone to wing it.
I want to go, what?
I said I want someone to wing it.
Not me. I want someone that knows what their stuff is, because a lot of times treatments can be timely. And I want my doctor to know what they're doing, and it's the same thing for a teacher. We need to know our craft. We need to know why we're doing what we're doing. We don't just wing it. You can, but you're not going to be as effective, okay? It's really important to know why we do what we're doing. We are better prepared to teach when we understand the science behind what we're doing. Okay? Say amen.